This section of chemical kinetics discusses reaction mechanisms. The sequence of events that describes the actual process by which reactants become products is called the reaction mechanism. Reactions may occur all at once or through several discrete steps. Each of these discrete or simple steps are known as elementary steps. The molecularity of an elementary step tells how many molecules are involved in that step. A unimolecular process involves only one reactant molecule. Bimolecular processes involve 2 reactant molecules, and termolecular processes involve 3 reactant molecules. Okay, let's zoom in on each type of process. So unimolecular processes involve only one reactant molecule. So the elementary reaction would be where the one reactant molecule A goes to products, and the rate law would be the rate is equal to K times the concentration of A. The exponent in the rate law may be derived from the coefficient of the reactant, which in this case is a 1. But keep in mind, this is only possible in an elementary step. Only possible in an elementary step. Not possible in a net reaction or overall reaction. Bimolecular processes involve 2 reactant molecules. There may be 2 different molecules, which you see here, A plus B, going to products, or there could be 2 identical ones, like you see here, A plus A. And the rate law, again, can be derived. The exponent, in the rate law can be derived from the coefficient of the reaction only for an elementary step. So for the first example here, rate is equal to K times the concentration of A squared. And that's because if I add these two, A plus A, this is 2A. So the coefficient would be 2. So my exponent is a 2. In the second rate law, rate is equal to K times concentration of A times concentration of B. Termolecular processes involve 3 reactant molecules. So we see 3 ways that we can have a termolecular process. In the first, we have 3 of the same, A plus A plus A, going to product. And so the rate law is K times A to the 3rd power. Once again, the exponent in the rate law, or the order with respect to that reactant, can be derived from the coefficient of the reactant. And that is only true if we're talking about an elementary step. Remember, before we said that you could only derive that exponent from experimental data. But if we're talking about an elementary step, we can use the coefficient. So in the second example, involving 3 reactants, I have A plus B, or 2A plus 1B. So we get a rate that says K times the concentration of A squared times concentration of B, or they could all 3 be different, A plus B plus C. So the rate is equal to K times the concentration of A times concentration of B times concentration of C.